So our next section is the chain rule. And the chain rule is when we have functions composed, one function composed inside of another one. And what we're going to wind up doing is taking the derivative of the outer function first, and then going back and taking the derivative of the inner function. So just as a little reminder of composition of functions, let's say I have the function g of x, and that function is x cubed. And then I have another function f of x, and it's x squared minus 5x plus 10. So if I want to compose these functions, so I'm going to call another function h of x, and h of x is going to be g of f of x. So that means I'm taking the f of x function and plugging it into the g of x function. So what I want to do is wherever I see an x at, I'm just going to leave a blank, and then I'm going to take that whole thing and cube it. So where there was an x, this is where I have my brackets, and I'm going to plug in the f function into it. So that would be x squared minus 5x plus 10, and that whole thing is being cubed. So what the chain rule tells me is when I take the derivative of this, h prime of x, then what I'm really doing is taking the derivative of the g function first. So I'm going to do g prime, and then the f of x is just going to remain, and then I'm going to multiply that by the derivative of f of x. So back to my example, I have x squared minus 5x plus 10 cubed. So that's my h of x. So my outer function is just something that's being cubed. So taking the derivative of that, it's just the power rule. So that 3 gets multiplied out front. Leave what's there alone for now, x squared minus 5x plus 10. And now this is going to become to the second power because I multiply it out front and then you have to subtract 1. Now I'm going to take the derivative of what's inside of there. So derivative of x squared is 2x. And then derivative of negative 5x is just negative 5. So the most I ever want to do when I have something with a power like this, because it gets messy, is I can multiply these two pieces together. So I would get 6x minus 15, and that's just multiplied by x squared minus 5x plus 10 quantity squared. So the outside function, we took the derivative first, and then we went back and took the derivative of the inside function. Alright, my next example, I have h of x is the square root of x squared minus 5. So I have the square root function, but then I have this x squared minus 5 composed inside of there. So the first thing I want to do is do a rewrite, so I can use the power rule. So that square root is just x squared minus 5 to the 1/2 power. So I'm going to take the derivative. So first, just treat this like it was a own variable. So I'm just taking something to the 1/2 power. So I'm going to go 1/2. Then that x squared minus 5, it becomes to the negative 1/2 power because 1/2 minus 1. And then I have to take the derivative of what's inside there. So I get 2x. And I can clean this up again a little bit. That 2 and the 1/2, they're just going to cancel each other out. So I have an x up top, and I can bring this back down. Since it's negative 1/2, I can bring it down. And if you want, you can rewrite it inside of a square root, or you can leave it as to the 1/2, x squared plus 5 to the 1/2 power. Either way is fine. Oops. All right, I have 1 over 3x squared plus 10. Sorry about that. And that's being squared. So this kind of looks like I have to use the quotient rule, but I really don't, because I just have that constant 1 in the top. I'm going to rewrite this as 3x squared plus 10. And because I brought it up top, now that's to the negative 2 power. So when I go to take the derivative, I'm going to multiply that negative 2 out front. And then this exponent becomes negative 3. And then taking the derivative of 3x squared plus 10, that gives me 6x. And I'm going to multiply that negative 2 and the 6x together. So I get negative 12x. And then I'm just going to bring that back down to the bottom. So we get 3x squared plus 10. And that is cubed. All right, for my next example, I have x to the 4th times 7x cubed minus 3 to the 4th. So I need to do a couple things here, right? I have a product because there's one function here and there's another function here. And then I also have something composed inside of here. So I'm going to use both the chain rule and the product rule. So g prime of x, I'm just leaving the first function alone. And then taking the derivative of the second one. So that 4 gets multiplied out front. And then this becomes to the 3rd power. And then I have to take the derivative of 7x cubed minus 3. And that gives me 21x squared. Now, I'm going to leave the second part alone. So 7x cubed minus 3 to the 4th. And then I'm taking the derivative of this x to the 4th. And that will give me 4x to the 3rd power. So I'm going to clean it up. I'm going to multiply these two pieces together. So that's going to give me 48x to the 6th times 7x cubed minus 3 to the 3rd power. And then the second piece is just the 4x cubed times 7x cubed minus 3 to the 4th power. So I have y equals 7x minus 9 squared times 8x plus 3, and that is cubed. So I'm going to need a chain rule and the product rule again for both of these. So to take the derivative, I'm leaving the first one as is and taking the derivative of the second. So I get 3 times 8x plus 3 to the 2nd power times the derivative of 8x plus 3, which is just 8. And then leave the 8x plus 3 cubed. Taking the derivative of 7x minus 9 squared, I get 2 times 7x minus 9. And now that's going to be to the 1st power. And derivative of 7x minus 9, I just get a 7. So there's not a whole lot I can do to clean this up. But I can multiply that 3 and the 8. So I get 24, 7x minus 9 squared, 8x plus 3 squared. And then I can multiply this together. So I have that 2. And the 7 I'm going to multiply to 14 times 7x minus 9 times 8x plus 3 cubed. And again, if you'd like to, you could distribute that as well. Of course, I don't have a calculator, so I'm not going to do it. And then one more And then you'll see that on your notes that I typed up for you, I have a couple of try it exercises. So I have 3x minus 1 over 2x plus 2. And then that's cubed. So this one I'm going to have to do the quotient rule as well as the chain rule. So starting with my outer function, which is just this thing cubed, I get 3 times 3x minus 1 over 2x plus 2 squared. And then the quotient rule. So we start with the denominator times the derivative of the numerator, which is just 3, minus the numerator times the derivative of the denominator, which is just 2, all over the denominator squared. And again, we can kind of play around and clean this up. So I'm going to first multiply this stuff out. So I would get 6x plus 6, and then this is going to give me 6x minus 2. So when you subtract those, 6x minus 6x gives you a 0, and then 6 minus a negative 2, I get 8. So that whole thing just has an 8 on top, 2x plus 2 squared on the bottom, and then I can multiply that 3 and the 8 together. So 24 times 3x minus 1 squared over 2x plus 2. It was a squared here and another squared there. So that 2x plus 2 is not going to have an exponent of 4.